Hello Prep 3 students, today we will explain the cases of image formation by the concave mirror and convex mirror. Recalling the rules that we are used to draw the images or the rules to determine the direction of the reflecting light ray that are incident on the concave mirror, we have three rules. If the light ray falls on the concave mirror parallel to the principal axis, it will reflect passing through the focus. And on the second case, if the light ray falls passing through the focus, it will reflect parallel to the principal axis. In the third case, if the light ray falls perpendicular on the mirror passing through the center of curvature, it will reflect on itself. So we will use two of these three rules, or the three rules itself, to draw the image inside the concave mirror and to find the properties of the image that are formed inside it. Let's start with the first case. If the light ray falls parallel to the principal axis, means that it comes from very distant place like the sun, so it falls parallel to each other. Each one of them will reflect passing through the focus. So the image will be collected here and forming a real image, which is represented by a dot. So if we are talking about the image formed in front of concave mirror, it will be dot. It will be real because it resulted from the collection of the reflected light rays from the concave mirror. Also, it's we can't call it inverted or upright because it's represented by a dot. In the second case, if the object is standing at a distance more than the double focal length, from the pole to the focus, it's the focal length. From the focus to the center, the same distance. So from the pole to the center, it's the double of the focal length, and the object is found at a distance more than the double focal length, so it's after the center of curvature. So one of the rays will fall on the mirror parallel to the principal axis, so it will reflect passing through the focus. It's the first rule. And the second ray, which comes from the object passing through the focus, then reflects parallel to the principal axis, and the image will be formed between the center of curvature and the focus. So we can call it inverted image. The properties of the image will be inverted image. Real because it's formed in front of the mirror due to collection of the reflected light rays. Also, it will be inverted, diminished or smaller in size, and real. The third one, if the light ray comes from the object which stands on the center of curvature itself, the first ray parallel to the principal axis reflecting passing through the focus, and the other passing through the focus and reflected parallel to the principal axis. Both of the reflected light rays are collected in the center of curvature itself, but the properties of image here is equal to the size of the object, inverted and real. The fourth case, if the object is found between the center of curvature and focus, we will draw the two rays, one of them parallel to the principal axis reflecting passing through the focus, and the other passing through the focus reflected parallel, and the two reflected rays are collected here after the center of curvature or at a distance more than the double of focal length. The properties of image are that this image is inverted and enlarged in size. Here the real size of the object, and here the size of the image formed. So it will be enlarged, inverted and real. And if the object is found at the focus, it's not drawn here. If the object is found at the focus, there is no image will be formed because there is no intersection of the reflected light rays or their extension. And what about if the object is standing at a distance less than the focal length between focus and between the pole? The first ray parallel to the principal axis will reflect passing through the focus, and the second ray can't pass through the focus because the focus is after it. So the light ray will fall on the mirror by a 90 degree. perpendicular on the mirror, it reflects on itself, and the extension of it will passing through the center of curvature. So we will take the extension behind the mirror for both reflected rays, and the image will be formed behind the mirror. So this image is a visual image, and the size of it will increase, so it's enlarged image and upright. What are the uses of concave mirror? We can use it inside the torch to reflect light or make it more condensed or more concentrated. In front lights of the car, in marine lighthouses to guide the ships, in aircrafts landing at airports to guide airplanes, in solar ovens like that, mirrors in each side to concentrate the light till reaching the food to can cook it faster. In the convex mirror, we have only one case. This is the reflecting surface of the convex mirror, and the object will be put in any distance from the mirror because there is no focus or center of curvature here. We put the object here, and we will draw the two light rays coming out of it. One of them parallel to the principal axis and reflect outside because it scatters the light ray, and the extension of the light ray will passing through the focus, while the other will hit the mirror, reflects on itself, and its extension will passing through the center of curvature. So the extensions of the two rays are meeting here behind the mirror. So the image here, we can call it as a visual image. It's upright and minimized in size. This is the same mirror that we can use it in case of side mirror car, which gives a smaller image to all the street and with minimized size and upright image. Also, we can use it as antithieve in the supermarket to give minimized image to all the supermarket and to watch it more clear. Here is a comparison between the real image and virtual image. The real image can be received on the screen while the virtual image can't, and the real image resulted from the intersection of all the rays that are reflected from the mirror in front of it, while the virtual image due to intersection of the extensions of the reflected light rays, not the rays itself. While in the real image it's always inverted or upside down, while the virtual image always erect or upright. The end of the lesson. Thank you.